Okay, so number 5. Determine the electric field at the origin due to the charges at A and at B. Okay, assumed to be, we'll assume, well, we always assume there are point charges that are concentrated in those points. Right. Okay, so the electric field here is going to be the sum of the electric field here due to this charge, let's call that EA, and the electric field here due to this charge, let's call it EB. So both are electric fields due to point charges, and we've got a formula for that which we used for this question. And if you look at that formula again, you'll see you only need the absolute value of the charge, which for both of them are the same. So the absolute value of the charge in both cases for A and B are the same, and the distance is the same in both cases. So great, the electric field EA, the magnitude of EA will be the same as the magnitude of EB, and that's a bonus, so we only have to calculate it once. Alright, in terms of direction, electric field here due to A, the EA will be away from A, because here a positive charge will feel a force in this direction due to this charge. So EA is in this direction, and how about EB? It is going to be in this direction, from here to in this direction, because a positive charge here will be attracted to this charge. So the electric field here due to this charge will be in this direction. Good. Okay, so I know the directions perfectly of both EA and EB, and I can easily calculate the magnitudes of EA and EB. So this is just going to be simple: calculate the two vectors and add them, and work out the components and get the direction. So overall, a well-rounded exercise. So I'm going to start question. So to have everything at hand, instead of scribbling on the sketch, I'll quickly recreate it. So I've got my X and Y there, and I've got B there. Let's try to roughly recreate it. So that is point B, and it is minus 26 microcoulombs, and that is A, and it is plus 26 microcoulombs. Right, and this distance is 8.0 centimeters. This distance is also 8.0 centimeters, and this distance also 8.0 centimeters. Okay, good. So I just quickly recreated everything. Now I know for calculating, I'm going to work with components eventually. So I'm going to need some angles to calculate those components. So what are they? What are the angles here? Well, this is equilateral triangle, so all angles are going to be 60 degrees. Let's use black. 60 degrees, 60 degrees, 60. Well, I don't need that. So I just need to know that this one is 60 degrees. Now this one is 30 degrees. Okay, that's because equilateral triangle, all the sides are have the same length. All right. Okay, now here at the origin, there's going to be the electric field due to A is going to be in this direction, as we just reasoned. So there's going to be electric field here due to charge at A, and here's going to be the electric field at the origin due to B. Right. Okay, so let's calculate the magnitude of EA. So EA is equal to, now that's just a straight formula for the electric field strength at distance r from a point charge Q. And in our case, it's going to be, let's substitute values. In this case, it really will be okay, definitely, to use this one. So I don't have more than two significant figures for any of the given values, do I? No, I don't. Right, so this one's definitely okay here. Okay, times absolute value of Q, so this is just plus 26 times 10 to the minus 6 coulombs, and over the distance squared, that's 8 centimeters, 0.08 meters squared. Right, and let's calculate this quickly. That's 9 times 26 divided by 0.08 squared. Okay, times 10 to the power what? 9 minus 6, 3. Okay, so it's a biggish number. Okay, so I'm not done with this number yet. This is not the final answer. I'm going to use it subsequently later on to calculate the magnitude of the electric field that I'm after. I'm asked to determine the electric field, so I need the magnitude and the direction. So I'm going to use this value to calculate the magnitude later on. So point is I'm going to use this later. So I'm going to provide some extra significant figures just to play it safe. Okay, so how many? 2, 4, 6, 7 newtons per coulomb. Right. And now very nice. EB is equal to EA. Since same charge magnitude and distance. Okay, if I apply this formula for B, it's going to be the same charge magnitude plus 26 microcoulombs. It's going to be the same distance, 8 centimeters. Right, okay, good. So I've got EA and EB strength, right. Okay, so what I'm after is the electric field, and this is now going to be the sum of the two due to the superposition principle of electric fields. Right, now I'm going to need the direction, so I'm going to need the x and the y component. So let's say so E's x component will be EA's x component plus EB's x component, and the same for y. Let's give myself enough space, so EY is going to equal EA's y component plus EB's y component. Right. Okay, now what is EA's x component? Well, it's 0. Clearly, you can see there's EA, that's perpendicular to x, so that's just 0 plus. How about EB's x component? Okay, so that's from there to there. What's this angle? Well, it is clearly 30 degrees. I can use the 60 degrees, but it's more natural to think of in terms of this 30 degrees. So it is going to be, it's positive or negative, it's positive, so this is just plus EB cos of 30 degrees, or if I use the 60, that would be sine of 60 degrees. Right. Okay, that is EX, and that is, okay, right. Okay, now, and how about EY? Okay, so what is EA's y component? That is simply just minus EA, and EB's y component, this is going to be not plus, actually. EB is in another direction, so this is going to be minus EB sine of 30 degrees. Okay, well, yeah, let's calculate both of them. Okay, so what is EB? It's times EA, so it is 3.656 times 10 to the power 7 times cos of 30. There we go, and this is well, let's do the same thing. It's still going to be 7 10 Newton per coulomb. Does that make sense? Yeah, it should be close to that value, a little bit less if it's cos of 30. Cos of 30 is a little bit less than 1. Okay, and this one minus EB minus EB. Okay, so let's just work out 3.656. I'm not going to write it into the 7, so this is times sine of 30, okay, plus 3.656, okay, so it's this much, okay, so this is going to be minus 5.484 times 10 to the 7 newtons per coulomb. Right, so there I have my x and y component. Okay, so now two things remain to get electric field. Its magnitude and its direction. Magnitude is easy. E's magnitude is just EX squared plus EY squared. That, in other words, is just, I don't feel like writing this again, so let's just plug it into a calculator. 3.1666. So this is, let's put where you can see, 3.166. I don't have to put that into the 7s there. You can put it if you're not comfortable with it, but it won't make a difference. And then to power 0.5. Okay. Okay, now let's just write the answer. 6.3. Okay, so this is a final answer, the magnitude. So this is now, I'm just going to provide two significant figures. So 6.3 times 10 to the, this is going to be 2 times 10 to the 7. I just took out 10 to the 7 as a common factor, and it's just a shortcut. Okay, and this is going to be newtons per coulomb. Okay, so that is the magnitude. Now for the direction. How do I get the direction? Okay, so x component is here, it's positive, and its y component is negative. Okay, so let's make that triangle. So I've got my ex component here, the y component there, so this is 3 point, see, now this doesn't quite make sense to me. This doesn't quite make sense to me. Why is this value more than that value? Oh, actually, no, that does make, okay, see now this kind of thing, this is a good habit to develop, you know, do the values make sense? I was now wondering, why is this value larger than this value? I mean, just looking at this, this value is this field EB's y component will be fighting this one's y component, okay, and that gives you this, but when you think about x1, why isn't it larger? Let's think carefully about it. Does that make sense that this one should be larger than that one? No, it doesn't. It doesn't. See, it doesn't. That doesn't make sense to me. I thought something was wrong here. Something was wrong here. You know, I noticed it doesn't. Just looking at that, if you add these two, why on earth would the y component be larger? See, notice here I made a mistake. So what is EA's y component? It's negative. But what is EB's y component? It's not minus that, it's plus that. Great. So let's redo that calculation. So that is going to be 3.656. Okay, so it's a times sine of 30 minus 3.656. That looks better. That looks much better. Good. Good. Always be vigilant. See if the values make sense to you. Just geometrically looking at it, it didn't make sense that this value should be larger than this value. Minus 1 times 10 to the 7 newtons per coulomb. Oh, okay, sure. Okay. Okay, so we take that thing squared plus this other one squared equals to the power 0.5. Great. So this is actually, let's just rub it up nicely. You can scratch out as much as you like, just do it neatly. Not the Bex. 3.7 times 10 to the 7 newtons per coulomb. Okay, yeah, that looks better. That looks better, much better. Okay, so x component there is 3.166, and this one is less. It is okay. So